Wireless Power Gathering Rectenna by Secure Supplies. Invitation to join our research on our wireless energy harvester circuit. Hi members and Patreon supporters of Secure Supplies, hydrogen hot rodding and nano bubble water fuels. Through Bitsy and our BTC SEC SEC Bitcoin Ethereum token project, we are embarking on an exciting open source research project where we invite you to participate, collaborate and innovate on cutting-edge wireless energy harvesting system. This project revolves around a rectenna, a rectifying antenna which has been advanced by Secure Supplies Group. It has a power conditioning circuit that captures and converts ambient electromagnetic energy into usable electricity. It is somewhat different to the EEC or electron extraction circuit, as this new power conditioning circuit has a auto-tune resonance capacitor section, similar to an auto-tune for a balun on an antenna. So the circuit is auto-tuning to the rectenna and gathering the electrons in such a way that it's turning them into DC and then stepping them up through a voltage magnifying capacitor array. Then it uses a DC to DC controller to allow 0 to 48 volts, adjustable to recharge your batteries or your cap banks for load and to do work. Whether you're passionate about renewable energy, wireless power transfer or electronics, this project has incredible potential and we need your experience to help test, improve, optimize this design and share it openly from researcher to researcher. My name's Daniel Donatelli. I'm founder of Secure Supplies Group, Hydrogen Hot Rodding and Bitsy Bear, the crypto technology bear. Here's a detailed breakdown of the system we're working on. Number 1, the rectenna is an array of antenna, most copper and aluminium receiving surfaces are joined by a capacitor and a one-way diode, thus creating a parallel placement of the diode and the capacitor between each antenna. Though the antennas are then wired in series, meaning that as they gather electrons and RF signal, it is turned to a usable DC and is compounded. The rectenna is the heart of our energy harvesting system. Its function is to capture electromagnetic radiation such as RF energy, Wi-Fi signals and other ambient energy sources and convert it into direct current DC electricity. This conversion allows, through the unique design that we've made, to be mass-produced and can be up to 1,000 rectennas could be then, which are basically small PCBs, mass-produced, could then be wired in series and joined together to make a large panel equivalent to a solar panel in size, or up to 1,000 rectennas or more could be in series, with the various adjustments made to the circuit once the testing and calculations are done for each antenna arrangement that's in series. This could also extract electrons and energy from liquids such as salt water from nature, like the sea, or a flowing river, or nanobubble water fuel. Basically the space in nature where there's shifts from gas to water or water to gas or air to water or rain to water or rain to atmosphere to rain, atmosphere to ground, rain to ground, anywhere in between there is able to extract power. Diodes we used were 1N34, 1N48, 4148, 1N4148, And these are known to be 5G panel diodes designed specifically as blocking diodes. Initially you might find it hard to find them, but if you do a search for the number plus blocking diode in the description, you'll see that they come up. These components rectify the alternating current AC which is received from RF signals or the surrounding nature. And the signal gathered by the antenna is then rectified, turning it into DC electricity and compounding it through the capacitors, allowing current to pass in only one direction and ensuring efficient conversion. The capacitors have an important role. These store the energy temporarily and help smooth the DC output, stabilizing it, allowing for some sort of load to the circuit, and making it ready for further use in an array structure. The rectenna design that we've made is after researching the performances of all the rectennas that have been done in the past, and we've put together the strategic progression of the best of those antennas. And it's basically multiple dipoles or multiple diode capacitor in pairs arranged in a grid to maximize the energy collection and improve its efficiency. Notes: we can put an additionally large aluminium black backplate on the rectenna PCB as a flat plate backing to help gather signals or electrons or electrostatic charges. Or we can use a spiral lily impeller using two copper tubes in parallel, made into similar to a lily impeller, but just with two copper tubes. And we can hang in the top of a pyramid, just in the top. And the pyramid could be made of a variety of different things. Ideally it would be made of copper, or it could be made from other things, could even be made from stone. And basically that will gather the Earth's electrostatic energy and focus to the top of the pyramid, and then go into our antenna. If our antenna is a lily impeller shaped one hanging inside of the top of the pyramid, it will work. It could also be aluminium plate on the outside of the pyramid, or it could just simply be on top of the pyramid hanging above the pyramid. All of these things work, and it's not essential, it's just one thing, not one way. There's many ways. You can just put it in the sky and hanging from a balloon or from a tree or anywhere basically. You can even work it on the ground. Or any standard antenna structure can support our rectenna. It can be on a satellite, it can be on a plane, it can be anywhere. The higher you go, the more you get. It will work in the inner city, anywhere inside of RF pollution area, and it will gather power, and the different shapes will gather electrons differently, and it's really not that difficult. So I've attached the PCB design, and you can add any sort of extension to it to sort of give it extra receiving sensitivities. Now, section 2 is the power receiving board that we've made. Once the rectenna has collected its energy and charged its caps, and it's made it to be DC, it's passed via an SMA connection and cable to the power receiving board. Here, the board performs additional voltage regulation, increasing the energy's utility. The board has an impedance matching circuit. So this is to ensure the maximum power is transferred from the antenna to the rest of the circuit. The impedance matching circuit minimizes energy loss and is not trying to pair it to a coil. It's simply trying to make it into the cap bank on the board with the most efficiency. The cap bank on the board is a Dixon voltage doubler. This clever circuit uses a combination of capacitors and diodes to further increase the voltage, making the harvested energy even more usable for various applications. It can be dangerous. We've tried to regulate it, so it can easily go to several hundred or thousand volts, but we've tried to keep it simple so people can learn the circuit and then make various adjustments as they discover the higher voltages. But basically, the Dixon voltage doubler is a series of capacitors and diodes and these components stabilize the voltage and protect the system from surges and fluctuations, ensuring that safe and consistent power delivery to our buck converter, which is DC to DC. The SMA connector that we used as point 3 was a sub-miniature version A, a connector that provides high efficiency and a link between the rectenna and the power board with minimum RF interference, allowing the signal to be transferred with minimal loss. It ensures a reliable connectivity for the high-frequency signals, making it ideal for energy harvesting. 4 is the buck converter on the energy harvesting power board. So after the Dixon circuit, on the same board, it just goes into a DC to DC onboard buck converter. And this converter takes the rectified energy and steps it down to the voltage to a more usable level, from 0 to 48 volts, adjustable. Whether you're powering a small electronic device or charging a battery, the buck converter allows you to adjust the voltage from the incoming DC down to a range between 1.5 to 48 volts, making it adaptable for a variety of applications, including charging capacitor banks, whether they're high-speed charging graphene capacitors or just traditional capacitors, or even just water or sand capacitors. It will charge them all. You can also recharge batteries, and the object here is just to have this thing on forever. You'll be constantly filling up your power banks, your batteries, your capacitors, for whenever you want to apply a load, and you can run your inverters and things off of those. And of course, it's completely scalable. I mean, there is no limit to how many you can have or how big you can design the system. The object of Secure Supplies providing this information is to give you a start, to give you the vision that this can be scaled. So the output of the energy harvest circuit, which includes the first step in rectenna and then the last step, the buck converter, we recommend it goes into a ZVS, a zero voltage switching circuit. And basically this will further tune the resonance of the circuit output to give you the maximum efficiency and give you a lot of voltage. This is particularly good if you want to make hydrogen, because voltrolysis, or the Stanley A circuit, wants that high voltage stable to come in and charge up the water fuel cell, remembering that it's nano bubble water fuel we want, not gas. Now, the final output from the power board can drive the ZVS circuit and be a very efficient system for powering inductive loads and enabling further bipolar coil wireless power transfers. This could be directly to a cell, wirelessly, or it could be from point to point, or it could be wirelessly charging your phone. Again, scalable, adaptable. One could imagine quite quickly a wireless car charger. The Stanley Meyer circuit can also be applied to this. There's not much you're adding except the gate. And then this can be employed for making voltrolysis, breaking the water molecules down into hydrogen, oxygen nanobubbles with the gated voltage. And then that nanobubble water fuel can be used at a later date. The diodes and capacitors and other parts in the circuit, which we call section 6, the diodes ensure smooth flow of energy, preventing reverse current, which could otherwise damage the circuit, and capacitors also help by storing and stabilizing the energy in such a way to allow the system to quickly release charge when needed. Zener diodes are very useful and help regulate the output voltage, preventing overvoltage conditions that could damage sensitive electronics. Sometimes you will see a variety of microwaves using Zener diodes. Section 7 is DC output. The system produces a stable DC output that can be used to drive other circuits, charge batteries or store capacitors. The versatility of this system we have designed by Secure Supplies Group makes it very suitable for many applications, from powering electronics to wireless transmission and renewable energy storage and voltrolysis, hydrogen, nanobubble water making. Also charging battery banks, capacitor banks, and using traditional inverters to run homes, air conditionings, etc. So if you imagine it as a decentralized power add-on, imagine an air conditioning being disconnected from your house power. You put a battery bank there that's sufficient to run it for a certain period of time, and then it's wirelessly charging itself. It's quite interesting. You're basically decentralizing the components in your house. They're not going through the one grid load. They're all individual wirelessly charged loads. So the summary of the system and its operation: energy is captured by the rectenna and converted from AC to DC via diodes. The DC signal is stabilized and processed by the power receiving board, which steps up the voltage if necessary using a Dixon voltage doubler. The SMA connector links the two boards and the array, if you've put multiple boards in series, rectenna boards that is, ensuring efficient energy transfer. The buck converter steps the voltage down to an appropriate level for further use. The Dixon voltage doubler also acts as a buffer, so it allows you to have power in reserve for a load. It's like a mini battery, a mini cap bank which you would be recharging. It's just a way of buffering the system internally, or if you like. The system outputs a clean, stable DC current ready for use in driving loads or powering other systems such as a ZVS or a voltrolysis system similar to Stanley Mears. Your skills, we believe, will help unlock this system's vast potential, and we want you to help take it to the next level. Whether you're an electronics enthusiast, researcher, or engineer, we welcome you to join us in this project. Together we can experiment, improve, and optimize the design to make it even more efficient, spread, and practical, and scalable. This is a decentralized project. Everyone needs one of these. Here's how you can get involved. Build and test the circuit. Buy the basic equipment from us. Support us on our Patreon. Study what we're doing. Join our Bitsy project. Use the provider's schematics and try building it yourself. Test its efficiency, tweak components, and provide feedback on what works and what can be improved, or your suggestions. All suggestions and improvements are welcomed. The more efficient the diodes, capacitors, and circuit designs, the better it will be for everybody. Share your thoughts and let's collaborate. It's very low cost, high gain, high productivity circuit. Share your results, upload your tests and videos to our Patreon and images to the platforms. Use email, Telegram to contact us so others can learn from your findings and build upon them. Let's innovate and push the boundaries of what's possible with this new wireless energy harvesting breakthrough. Join the conversation, share your thoughts with us, and be part of this cutting-edge project. We look forward to seeing your contributions and your applications for this amazing technology. Best regards, Daniel Donatelli, Secure Supplies team.